Okay, we are starting the review. Before we do that, you did have an assignment yesterday. It was green and it was 9.4, practice 2, and it was working on, going back to our flip book, writing equations if you're given the zeros or the x-intercepts at another point. If you didn't get a chance to check that with the sub, I'm going to share the answers with you now. Okay? So again, we're working with this equation. You take a, because that's what we're going to solve for, and x is the 1, plus the opposite, so -3, and then another set of parentheses with x, and then plus the opposite, so I use 1, and then it's going to equal the y. You work on getting your parentheses simplified, so -2 and 2, and then multiply that along with the a to get -4a, and then to solve for a, I just divide by -4, and I get -2/4. You could put -1/2 or 0.5, and then you get your answer. Okay, so we already done that one together, but here are the other answers. Here's my work. That is scribbled out. Okay, so again, my x is 6. My opposite numbers are 10 and -5. I go through and do the math. Hopefully I didn't make any mistakes. I get 4a. To solve for a, I divide by 4, and I get -1 for a, and then I can put it in the equation. And again, the equation x and y will stay as x and y. Don't put those numbers back in. And then here's the last one. Okay, so again, my x plus the opposite of p and the opposite of q. You can go through and do your math. You multiply, divide, and then the negative divided by the negative is just a positive. You could have had this in there too, or this here, and then that's an x, and there's the answer for that one. So anyway, that is as far as that goes. We are now going to be working on the review. You should have gotten a green review from the substitute. So if you didn't do that, well, go get one. And you need your flip book. And we are going to be adding one more thing to our flip book when we get to that particular topic. So mine's white. I've got some extra paper in case I need some more room. Maybe you want some extra paper as well. And let's just go through these. So below is a quadratic equation given in 3 equivalent forms, and you need to tell which points you gain from each form, and then you're going to graph it. Okay? So first, in our flip book is the top left. Here's our 3 forms. We've got standard form, which gives you the y-intercept, C. We've got vertex form, which gives you the vertex. It's the opposite of h and k. And then we've got factored form, which are the x-intercepts. And it's where you take the opposite of this and this. And then between those things, you can get a pretty good graph. So the idea is, you know, these are all the same. They're all equivalent. The work's been taken to get you from one to the other. So just what is each form going to give you? So first, this form, this is our factored form. And the points I'm going to take the opposite of this. So -2, there's 1 x-intercept, and then -4. And then I can come over here and graph them. So -2 and -4. This is standard form. And what I can get from there is the y-intercept. It's 8, but we're going to write it as 0, 8. So I can get that graphed all the way up here. And then from this is vertex form. And again, you take the opposite of h, so -3, and you take that one as is, -1, and that is your vertex. So I'm going to go over 3, down 1. And then to draw the full parabola, what we would do is draw on that axis of symmetry. And then every point has a partner point, so except the vertex. So these are partner points, and to get this one, if this is over 3 to the right, I'll just go over 3 to the left, and then you can get your parabola. Okay? Alright, one thing I want to start to talk about is A, and what A does when you move from the vertex. So in all of these problems, if I need an A in front, I'd have a 1, a 1, and a 1. And whatever A is, if you start from the vertex, will tell you how many you can go up, and then you always go over 1 to get to the next set of points. So since A is 1, I'm going to go up 1, and then I'll always go over 1, and I can get to the next set of points. So just something I want you to start to notice. Okay? All right, number 2, you're given the quadratic function. This is in standard form, and we're going to write it so that we get the x-intercepts. So, again, x-intercepts mean we're going to need to factor this for factored form. Okay? So, I'm going to take this, I'm going to make my x. That's 6x squared, and then the middle term, 5x, goes in the bottom. So I need factors of 6 that get me to 5. You're going to use 2 and 3 with x's, and then we're going to rewrite it, but instead of 5x looking like this, it's going to look like this. So you still have 3x squared, you still have the 5x, and you still have 2. And then you can group them. And in the first set of parentheses, what's the most you can take out? So what's the biggest number you can take out of 2 and 3? That would just be a 1. And if you want to write the 1, you can, but you don't need to. But you can factor an x out of both of those. And then x times what gives you this, and that's 3x. And x times what gives you 2x, and that's 2. And then you'll need another set for the matching parentheses. And then you'll want to figure out what times 3x gives you 3x, and that's 1. And so now we can have it in factored form. The things on the outside, the x plus 1, and then the matching set is the other side. So when the directions say rewrite it so you can see the x-intercepts, we can see the x-intercepts. So B just wants to know what they are. And it's just what makes these equal 0. So what makes this one equal is -1. That one's pretty easy to see. This one's a little tougher to see, so I can always set it equal to 0. Subtract 2. Divide by 3. And here's the other x-intercept. So these are the x-intercepts. The y-intercept I could just tell in the original form in standard form, and that was the 2 there. So the y-intercept is 0, 2. All right, number 3. So this one is given to you in standard form, and this time we want to get it in vertex form. And to do that, we need to complete the square. So this is where you group your x's, and we're going to put the, if you add the opposite, the -9 on the, not with the x's. Before we can complete the square, it's got to be just x squared, so I'm going to factor a 2 out of both of these. And then we start to make the blank of what we're going to be adding and then subtracting. So I'm going to take this 4, not 8. I'm going to cut it in half, that's 2. I'm going to square it and get 4, and I put 4 here. So even though I've written 4, remember this 2, when it distributes back in, really makes this term worth 8. So now we clean it up. So I'm going to start here. I'm going to add the opposite, and then you can see that it's -17. You'll have your set of parentheses squared with the 2 in front, okay? And then it's going to be x plus your cut in half number, this 2. And now this is in vertex form. And now when I look at it, I can see the vertex. It's the opposite of 2, so -2, and then the k as it is, -17. So there's my vertex. And then the y-intercept, again, I could tell that in the original form. It's, if you add the opposite, it's -9, so 0, -9. All right, moving on. So same thing this time. You're given the function. This is in factored form, and we're going to want to see the y-intercept. So again, I'm getting all of this from this form here. So if I want to see the y-intercept, I need to get this in standard form, which means I'm just going to have a lot of multiplying. And when you've got 3 factors to multiply, 2 with x minus 2 and with x plus 2, we agreed that we were just going to always multiply the parentheses first. So this is where the neighbors go and visit the neighbors. So x is going to visit first. You're going to get x squared, and then if it's the 2, and you got 2x, and now -2 has to visit the neighbors, and you get a -2x, and then you get a -4. And I'm going to just clean this up. I can combine those like terms. Those actually cancel out. And now the 2 that I haven't multiplied will multiply in, and I can just distribute it in. So I get 2x squared and -8. So what's missing from this is just the regular x. So I guess if you really want to put a regular x in there, you could. It would just be 0x, but you don't need to. Either of these would work. Okay, so now when I look at it, I can see the y-intercept, and it's negative 8. So we've rewritten it so we can see the y-intercept. That's actually the question here. So here's rewriting it, and the y-intercept is the negative 8. And the x-intercepts are going to come from the factored form, and what makes your factors equal 0. So 2 and negative 2. And you can write it as 2, 0 and negative 2, 0. All right, next we are moving on to solving. This is the back of your flip book, and you need to decide. This is good mile marker practice. Is there one type of x, or are there two types of x's? So again, I always go through and I look for the one type of x first. We're doing the square root method, and if you don't remember, go to the front of your flip book. Square root method is where it's one type of x. X wants its own room. We work backwards in the order of operations. And don't forget the exponent, you get rid of it by square rooting it. So which ones have just one type of x? That'd be 5a, 5c, and that's it. So we're going to do those first. So I'm going to make my little order of operations list backwards. And let's get x's own room. So the first thing I'm going to move is the addition subtraction. So I'm going to add 3. And that's going to give me 32. The next thing I'm going to move is the multiplying and dividing. 2 is multiplying to the x squared, so I'm going to divide by 2. That gives me 16. And now I'm going to get rid of the exponent by just square rooting. And remember, when you square root, your calculator will tell you 4, but you're going to need to remember that it's also negative 4. Those are our two answers. If you go to C, same thing. X wants his own room, so we're going to work backwards, make that list again. And the first thing we're going to move is the 2, so our addition subtraction. Not this, because this is in the parentheses, so we're going to subtract 2 first. And we're going to get 77. And then maybe, so there's no multiplying and dividing. Now we're going to get rid of the exponent, so we're going to square root. And right now we have x minus 4 with the positive and the negative version of the square root of 77. So this is where you need to get your factor program or your factor page and just look, are there any factors of 77 that are perfect? And they're not. So at this point we have two problems. We have x minus 4 with the square root of 77 and x minus 4 with the negative version. And the negative's on the outside, not on the inside. Either way, to get x by itself, I'm going to add 4. And it does say leave your answers as radical, so we won't need to turn this into a decimal. So it's going to be the square root of 77 added to 4. These aren't like terms, so we're just going to leave it like this. And then the other one is going to be the negative version, once I add 4, of the square root of 77 and adding 4. So those are my two answers. If you really want to see what that's worth, you could turn on your calculator, do the square root of 77. You would need to close the parentheses, and then you could add 4. So one answer is like 12.8 if we round it. And then I could do that again, but just make sure I put a negative. Okay, hopefully flip in front of the square root of 77, and then add 4. And so the other answer is negative 4.8. So if you really want the decimals, those make more sense to us, but the directions didn't say to do that. All right, otherwise, if there are two types of x's, which the rest are, standard form, factor, or quadratic formula. So the first thing I notice is actually d. D has been factored for us. So I just actually have to see what's going to make those equal 0. So 2x minus 3, what will then make that 0? And 5x plus 1 will make that 0. So I'm going to add 3. I'm going to divide by 2. And you can leave it as a fraction, you can turn it into a decimal. And this one I'm going to subtract 1. Then I'm going to divide by 5. And again, you can leave it as a fraction or you can put the decimal version. So either way works there. Okay, so moving on, let's take a look at the others that have more than one type of x. So we are going to attempt to factor. Okay, and if you can't factor, you're sad, so you sing yourself a little song. You go to the quadratic formula. So first I'm going to factor. I'm going to get negative 10x squared and 4x. And then I would look at my factors of 10 to see if any of them could get me to 4. And between 1 and 10 and 2 and 5, I can't get there. So we can't factor. So we're sad and we're going to sing ourselves a song. And A is 2, it's next to x squared. B is 4, it's next to x. And C is negative 5. So remember, to figure out what x is, it's opposite b, so negative 4, plus or minus, and we're going to have this big square root, and now I'm going to take b and square it, so 4 squared. And then minus 4 times a times c, and it's all over 2a, so 2a, 2 times 2 is 4. And then you can go to your calculator and type what's inside that square root. So 16 minus 4 times 2 times negative 5. So 16 minus 4 times 2 times negative 5. And we're going to get 56. And this is a really good answer. Again, they want you to just leave it as a radical. So what I would see is if I can simplify 56. So if you go to your factor page, 4 and 14. So you could break that 56 into the square root of 4, right there, and the square root of 14. And then the way they want the answer is negative 4 plus or minus. We'll turn that into 2 with the square root of 14 over 4. Now, we never went for just those answers. We actually would have done then negative 4 plus 2 square root of 14. Hit enter. And then what we would have done is divide by 4. So 0.87 is one decimal answer. And then I would have done negative 4 minus 2 square root of 14. Hit enter. And then divide by the 4. And there's my other decimal answer, so negative 2.87. Okay? So again, that's the answer that they want. This is the answer that makes more sense to us. All right, E. So first, E is a little bit different because it doesn't have 3 terms, but there is still more than one type of x. So what we learned a while ago is sometimes when you factor, you can only factor out the greatest common factor. So for instance, I can take a 2 out of both of those, and I can also take an x out. And then when I'm done, 2x times what gives me x squared? That's x. There's the minus sign, and 2x times what gives me the 4x, and that's 4. Or sorry, that's 2. And then you can set these equal to 0. So what makes this equal 0? That's pretty simple. That's 2. If you don't see what makes that equal 0, set it equal to 0. To solve for x, I need to divide by 2, and you're just going to get 0. And the last problem, this one is not in standard form. I'm going to move the 30 over to join the 2 by subtracting it. And that's going to give me a negative 28. So now I'm going to factor. So I need factors of negative 28 x squared to get me to 12x, or negative 12x. And that's going to be 14x and 2x, but I'm going to have to make the 14 negative. And now I can rewrite it, but instead of negative 12x looking like this, it's going to look like this. So x squared minus 14x plus 2x minus 28, or plus negative 28 is how I'd have written. And then the 4 terms, we'll group the first 2 and the last 2. And here the most I can take out is an x. And then x times what gives you x squared is x. And x times what gives you 14x is the 14. So when you go here, you need a matching set. You need another x minus 14. So what times x gives you 2x? That's 2. And then just double check, does 2 with this minus 14 give you a negative 28? And it does. And now you can get your 2 sets of parentheses, the stuff on the outside, so x plus 2. The matching parentheses is the other set. And now what makes these 0? These are pretty easy to see. One answer is negative 2, and the other one is 14. So again, where we looked in our flip book is mainly the back. But if you don't remember certain things, then you can go to factoring. We did remind ourselves of the difference of squares. Oh, and we did put the greatest common factor. So that's what would have happened here. Greatest common factor was a 2x. And we haven't seen that much of difference of squares. A lot of them have just been the x. We had some quadratic formula and the square root method. All right, moving right along. We need to graph each of the following. So make sure you include the vertex and 4 additional points. So, we've got quite a few different ways to graph. We're going to start out with this form, and I think the form that most of us seem to like the best is with the transformations. That's what I asked you guys about on Tuesday. What is it that you like? So first what we're going to do is just look at it. We're going to do this one first, and just figure out what are the transformations. So the negative is going to make it flip. The 2 is going to make it stretch. This 1 remember, we always do the opposite of what's in parentheses. It'll go left 1, and the 3 will make it go up 3. And I know all of this because in here I said what A did, I know what H does, and I know what K does. So from there, you need to make your T-chart with the parent function points. So I'm going to do that right here. And so I have -3, -2, -1, 0, 1, 2, 3. And then the parent function again is x squared. So all I'm doing is squaring these. So this squared is 9, 4, 1, 0, 1, 4, 9. So what we do is first is we apply our flip, our stretch, whatever A is, into our table. So what we're going to do is we're making a new y, and we're just going to take all of the old y's and multiply them by this -2. So we're going to have a new y, -18, -8, -2, 0. Again, I'm just multiplying by -2. And so what's going to happen now is we're going to graph these. Not those y's, but with these y's. The first set won't make it in the graph. It's just not going to fit. So I'm just going to graph -2, -8, so over 2, down 8. -1, -2. Here's 0, 0. Here's 1, -2, and 2, -8. And there's your U. You have the vertex. And, oh, sorry, I'm not done. Sorry. What I still need to do is go left 1, up 3. So now I'm going to take these points and go left 1, up 3. So left 1, up 3. Left 1, up 3, each point. Left 1, up 3, left 1, up 3. And the x's are the actual final parabola. That's the original one. So again, I want to talk to you about what A does and what A does in a graph. So if you go to your vertex and you take a look at what A is telling you that from the vertex, if you go down 2, and then you'll always go over 1, you'll actually get your next set of really nice points. So this A being -2 says from the vertex, go down 2, always go over 1, and you should get your next set of nice points. Okay? It's not down 2, over 1, down 2, over 1, but it does work on the first set. So this one. If you really like graphing like this, then what we need to do is complete the square to get it into vertex form. So that's what I'm going to do over here. I'm going to group my x's together. I'm going to leave this blank. Here's the non-x. I am going to add the opposite on that -5. And I'm going to look at this 4. Make sure you look at it as -4. I'm going to cut it in half, and that's -2. I'm going to square it, and -2 times -2 is 4. And I'm really just adding 4, so now I'm going to take away 4. And then here, just so we don't mess up, I'm going to add the opposite. And I'm going to get -9 outside the parentheses, or -9. And then in the parentheses along with x will be x and my cut in half number. Okay? Alright, so what's happening now to our parent function? So again, I think we're just going to stick with the transformations. So the idea is A is 1, so it's not going to stretch or compress or flip or anything like that. But this says it's going to go right 2. And this says it's going to go down 9. Whoops, down 9. Okay? So, again, we would take our parent function, T-chart, same points as here, so x is -3, -2, I'm just drawing it a different way, -1, 0, 1, 2, 3. I would then square those numbers for the parent function. And again, this list is in your flip book. Now, there is no A. A is 1. So if you just multiply these by 1, you're not changing it. So I don't have a stretch or compress, so I won't have a new y. So I'm just going to graph these. So -3, 9. Here's 3, 9. Here's -2, 4, 2, 4, -1, 1, 1, 1, and 0, 0. And now I'm just going to follow the other transformations. I'm going to go right 2, down 9. So let's use a different color. So right 2, whoops, and down 9 lands that point right here. This one right 2 and down 9 lands it here. This one's going to go right 2 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's going to go right 2 and down 9. This point's going to go right 2 and down 9. So I won't right 2, but 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's going to go right 2, down 9. And then finally my vertex, right 2, down 9. And then you get your new U. So I think we're going to stick with the way of graphing quick and easy in vertex form. And again, you need to know what A is. H, you always do the opposite of H. It's in the parentheses. That tells you left, right. K tells you as is. You make your T-chart. Your A, if you want to do this, does apply to your T-chart. You'll make a new Y. And sometimes you won't have an A. So going back to that A, in this one, A is 1. So the idea is from the vertex, I can go up 1 and over 1 and get to my next point. So A is, again, about how many go up, and then you always go over 1. All right? Okay, so the idea is, going back to this, what are the transformations? And we have the transformations here. There are parentheses here, so if you don't have parentheses, we'll need to add some. So, like this one has everything. So let's talk about what each thing does. So half. This is less than 1. Remember, that's in your flip book. So when it's in between 0 and 1, which a half is, it's going to compress. So that's going to make it compress. I look at this and see -2, so I'm going to do the opposite. That's 2, and it's going to go right. And this says to go up 3. Okay? So real quick, if you were to graph this one and you've got your vertex right here, to get to the next easy point, I would go up a half and over 1 and get those points. So just, again, I want to keep stressing what A also does. So this one has something in the parentheses, but it doesn't have anything added outside. So I can add 0 and that doesn't change it. So A is 1. 1 doesn't stretch or compress. That's normal. So I'll go inside the parentheses and take the opposite, and that means I'm going to be going left 1. And this means there is no up or down. Okay, and so you don't even have to write anything for up or down. This one is missing parentheses and the stuff added on. So I'm going to do -3. And then parentheses, again, normally is x plus something squared like this. So if I have to add something that doesn't change it, it'll be x plus 0. And then if I have to add something on the outside that doesn't change it, that's 0. So this negative will make it flip. And the 3, since that's bigger than 1, that will make it stretch. And that's it. It won't be going left or right, and it won't be going up or down. And the last one, this is missing parentheses. So again, if you need to add something in your parentheses that doesn't change it, it would just be 0. So there is no A. It's not stretching or compressing or flipping. There's really, technically, it's 0, so it's not going left or right. Instead, this -4 means it's going down 4. Okay, we're going to finish this up. So I need for you to get your flip books out. I don't have my actual flip book. I had to take a pause in the video, so that might be why this is a little odd. What I need for you to do is go to the bottom right corner of your flip book, the one that we've left blank so far, and write A in the vertex. And we're going to talk about the relationship between A and the vertex and how you can figure out A if you actually just have the vertex. So write that down and then open up the flip. So imagine I've opened it up and this is what's underneath. And this is what I want you to write. So basically, if you take your A and you put it over 1, this is considered like a rise over a run, a one-time rise over a run. So what happens if you have the vertex, okay, so you've got your U, you know, and you've got your vertex, you can take your A, and if you go up whatever A is and over 1, you're going to get to your next set of nice points. And by nice points, I mean points that are what we call the lattice points. They're easy coordinates to figure out. So on your review, you already have these values on here, so I'm going to have to rewrite them because this is a new copy. And so you should have had 0, 5 here. You should have had, 0, 5, 0, 3. And then you would have had, for this point, you would have had 1, 4. And then over here, you would have had -1, 4. And then on this one, this is now 1, 3. And then our next set of points that are very easy to read is this one. So that's 2, 5. And again, this is already written on your paper. And then this one at 0, 5. All right, so let's talk about the what this question wants. So it says, describe the translations and transformation necessary to turn f of x into g of x. So the first thing I'm going to do is just pick a point. The vertex is the easiest point, and just see what did I do to go from 0, 3, so here's 0, 3, to get to 1, 3. Oh, it's getting a little blurry. And the only thing I did is I went right 1. So that's one transformation that I had to do. The other thing that I want you to look at is this u is a little bit skinnier than this u. It actually got stretched out. So that means a is different. And so if you go from your vertex to the next nice easy point like this, if you go up 1 and then over 1, this top number is the a, what I was referring to here. So here a is 1. But if I go to this one and I go from my vertex to the next easy point, then I go up 2 and over 1. And it's always over 1. So here a is 2. So in this problem, a is 1. And in this problem, a is 2. And since a is bigger than 1, the other thing that it did is it stretched. Okay? And it stretched by 2. And I know it's 2 because I go up 2 and over 1. How many do I have to go up so that I can go over 1? And that was 2. All right? Okay, let's move on to number 9. So given below are two different quadratic functions. We got to figure out which function has the highest y-intercept. So if you look at this one, you can already see the y-intercept. That is 0, 24. So what we need to do, and if you look in your flip book, is this is vertex form. This is the top left, the 3 different forms. I need to get this into standard form so that I can see the y-intercept. This is not the y-intercept. So if you remember that x minus 6 squared means there's actually 2 of them. Okay? And when we talked about the 3 different things that there are to multiply, we agreed that we were always going to multiply the x's, or the parentheses. So I'm going to multiply, whoops, and I'm going to get x squared and a minus 6x. Maybe you want to add the opposite. And then I'm going to multiply again, negative 6 visits, and I get another negative 6x, and then negative 6 visits that, and I get a 36. So this is still just the stuff in the parentheses. I'm going to add these like terms. And now the thing that I still have to multiply of the 3 factors that I up here is the negative 2. So now negative 2 is going to multiply into all of these. So I get negative 2x squared, I get 24x, and I get negative 72. And then I don't want to forget the 95. And then to get it cleaned up, I'm just going to add those 2 plain numbers at the end. And if I take negative 72 and I add 95 to it, you can use your calculator, you're going to actually get 23. And so now when I compare the y-intercepts, this one is a smaller one than this one. So which one has the higher y-intercept? That would be function B. All right, we're going to write a quadratic function with x-intercept. So this is on your flip book. It's under writing an equation. We have the x-intercept. So if you open up your flip book, you're going to see this equation. I think my pen's going to die here. And we're just going to put the right numbers in the right spot. So I'm going to start with A, we'll be figuring out. X, this is X. These are the zeros, or the x-intercepts, they even told me. And then this is the other point. So I'm going to put 0 in for X. And remember, this means you do the opposite of this. So I'm going to put in 2. And then I'm going to do X again. And I'm going to do the opposite of the other one. So I'll put in negative 4. And then it's going to equal the y, the negative 24. Well, that's not a very good negative 24. So what I'm going to do is add these up. Add these up. In the end, these are just multiplying. So once I multiply those all together, I get negative 8a. And when I'm done, I'm going to get that a is 3, getting a by itself. So now I can write the equation. In our flip book, remember, you leave x and y alone. You just put a back in, your opposite of p, and your opposite of q. So when I'm ready to write this, I'm going to have a. X is left alone with the opposite of p. X in the opposite of q. And then equaling y. All right, so let's go to number 11. A watermelon is thrown from the roof of a 20-foot building, and after 3 seconds, it reaches a maximum height of 30 feet. So we're going to draw a picture. Here's my building. Here's the ground. Here you are. Here's your watermelon. And you're going to throw the watermelon like this, and it's going to land on the ground and then break. So the idea is it starts at a height of 20 feet. Where it starts is the y-intercept. So that's going to give me a point right here of 0, 20. And then it says after 3 seconds, it's going to get the highest height. So after 3 seconds, now it's at 30 feet. And what I need to do is write the equation. So when I look at what I have the vertex and another point. So my flip book tells me to use this equation. And I'm just going to put all the numbers in where they need to go. So remember, we're always trying to figure out what A is. This is the other point. This is the vertex. So I'm just going to put X in. I'm going to put 0. I'm going to do the opposite of the H. So I'll do -3 squared. And then K. And then I'm going to come back to this one and put my Y in. So now what I'm going to do is just clean this up so I can figure out what A is. I'm going to add these up and get -3. -3 squared is 9. So I'll have 9A. Now to get A by itself, I just got to subtract the 30. So it gives me -10 over here. And now to get A by itself, I divide by 9, and I'm going to get -10/9. If you really want to put the decimal version, you can. But now I'm ready to write the equation. And again, when we write the equation, X and Y are going to stay X and Y. So in for A goes my -10/9. And then X plus, again, the opposite of H, the vertex. Your K, leave it as it is, equals Y. And if you really want to see if you're right, a couple things you could do is, like on this one, just go to Y equals, put this into Y1, go to your table and see if these numbers are in your table. And then go to this one, put this one into Y1. If you're going to put the fraction in there, you will have to put that in parentheses. And then go to your table and see if these points are in there. Okay, let's go to the last page. Okay, so next problem. We got another word problem. A diver jumps off a 16-foot diving board into the water and reaches a minimum height of 3 feet after 3 seconds. So we're going to draw a picture and write the equation. So here's our diving board. Here you are. And you're going to, it actually should say diving in, because if this is the water and it says you reach a minimum of 3 feet, it's saying that you're going 3 feet below the water. So the lowest you're going to get, you're going to start at 0 seconds, you're at 16 feet. And then after 3 seconds, you're 3 feet below the water. So your height is actually considered a -3. All right. So again, when I look and what I have is I have the vertex and I have another point. So I'm going to be using this. And I'm going to be putting in the necessary numbers to get A. So A will be A. This is the X and Y, so I'll put 0 plus the opposite of H, so 3 will give me -3, plus K, so -3, and then that's going to equal back to that Y. And again, go to your parentheses, that's -3. -3 squared is 9, so here I'm going to get 9A. And now I'm just going to solve for A, get A by itself. I'm going to add the 3 over. That gives me 18, and when I divide, I get A to be 2. And now I can put A in the opposite of H and K back in, and we leave X and Y as X and Y. So when I'm done, I get 2 of X plus, again, the opposite of 3, so -3 squared, plus my K, which is -3, equals Y. And again, if you want to see if this is right, go to your graphing calculator, put this into Y1, and see if this number or these points are in your table, and so is this one. All right, this one. So again, I had to reprint this. So let me get these points on here real quick. Let's see. This one is... Okay, so sorry. 0, -5. This one is -2, -5. And this one is -1. negative 4. Okay? And then this point, I would have given you this as 3, 1. And I would have given you this point as 4, negative 1. And I've given this point to you as 2, negative 1. So again, we're going to write the equation. In both equations, you have the vertex, and you have 2 more sets of points. So you just have to decide actually which set of points you want to use. So in this problem, we have to use the vertex. And if I have to choose between the two, I chose the set. So again, I'm going to put them into here, all on my flip book. I'll be figuring out what A is. X is going to be the 0 because that's your vertex. So 0 plus the opposite of negative 1, so 1. Plus my K, the negative 4. And then that's going to equal the Y. So again, do your parentheses, that's 1. 1 squared is 1, so you get 1A, which is just A. And now to get A by itself, just move the negative 4 by adding 4, and when you're done, you get A to be negative 1. And then you can put your A and your vertex back in, leave X and Y as X and Y, so it's going to go negative 1. It's going to go X plus the opposite of negative 1, plus my K, and that's going to equal Y. And the last problem, same stuff. We got a vertex and another set of points. I believe I had chosen this point when I did it. So there's my X and Y, there's my vertex. So I'm going to put them into here as well. Let's rewrite it. So A will figure out, for X I'm going to use 2, plus the opposite of H, so 3 will give me negative 3, plus my K, which is the 1, and that's going to equal Y, so back to the negative 1. Again, I'm going to just get my parentheses, add them up. That's negative 1. Negative 1 squared means negative 1 times negative 1. That's 1. So I'm going to get 1A, which is just A. And now to get A by itself, I'm going to subtract 1. And A is negative 2. And now I can write my equation. A, X plus your opposite of H, squared, plus your K, that 1. Sorry, I know it keeps going in and out for blurriness, and then you're done. And again, just going back to that last part about the vertex and A being a rise over run. How many do you have to rise before you can run over 1? And if you look at this one, if A is negative 2, so we're not actually rising, but that means I should be going down 2 so that I can go over 1. And you can see that in the picture. And then here, A is negative 1. So that means how many I should be going down 1 so that I can go over 1 to get to my next point. So just a little thing about A. And that's it. That's your review. Test this tomorrow. We'll probably have to move it into Monday as well. That's it.